Okay, so now we have a problem associated with Hess's law. And in this question we're asked to determine the enthalpy change for ethanol. And the reaction that we've got is shown here. We have ethene, C2H4, reacting with H2O, that's water, to produce ethanol. And the information that we're given are enthalpies of formation of each of the three compounds in this equation: ethanol, ethene and water. Okay, so the first part of the question asks us to write down the thermochemical equation for the three enthalpies of formation. The first formation reaction involves ethanol, so we need to write down an equation that has as its product 1 mole of ethanol, C2H5OH. Okay, that's the product. And that will be formed from the elements that are contained within that molecule. So it's going to be formed from carbon, from hydrogen, and from oxygen. Now notice how I've written hydrogen and oxygen, because as naturally occurring elements they occur as H2 gas and O2 gas. Okay. Now this is going to be fairly straightforward to balance because we don't change the number of molecules of ethanol produced. When we're interested in the enthalpy of formation, we are forming 1 mole of product. Okay. So we simply look at the number of carbon atoms on the right hand side, which is 2, and we then have to put a 2 in front of the carbon atoms on the left hand side to give us 2 carbon atoms. We then count the number of hydrogen atoms on the right hand side, which is 6, 5 plus 1. We then need 6 hydrogen atoms on the left hand side of this reaction, which means we have to put a 3 in front of the H2, because 3 lots of H2 gives us 6 hydrogen atoms in total. Looking again at the ethanol, we see that we have 1 atom of oxygen per molecule, so we also need 1 oxygen atom. Now each molecule of oxygen provides 2 oxygen atoms, so we only need half a molecule of oxygen to give us 1 oxygen atom, which balances out with the oxygen atom on the other side. Now, a thermochemical equation gives a balanced chemical equation, but also the associated enthalpy change. And in this case, the associated enthalpy change is the enthalpy of formation of ethanol, which in this case is minus 277.7 kilojoules per mole. Okay, so that's our balanced thermochemical equation for the formation of ethanol. The next equation that we have to write is for the formation of 1 mole of ethene, and the associated reaction will be the following. Again, it's composed of carbon, and in this case only carbon and hydrogen. Okay, so what we have to do is, again, to balance this equation, we're going to have to put a 2 in front of the carbon to give us 2 carbon atoms on each side of this reaction. We have 4 hydrogens over here, so we need 4 hydrogen atoms over here, which we obtain from 2 hydrogen molecules. So that then is a balanced equation for the formation of 1 mole of ethene, and the enthalpy change for that, to complete our thermochemical equation, will be 52.3 kilojoules per mole. Finally, we are interested in the formation of 1 mole of water. And 1 mole of water is produced from hydrogen gas and oxygen gas. Elemental forms, remember, H2 for the hydrogen, O2 for the oxygen. We need to balance the hydrogens. We've got 2 on this side and 2 on this side, so that's perfectly balanced. We have 1 oxygen atom over here, so we need 1 oxygen atom from this side. Each oxygen molecule produces 2 oxygen atoms, so we only need half. That equation is then perfectly balanced. We assign the associated enthalpy change to that reaction, which in this case is minus 285.8 kilojoules per mole. There we have 3 thermochemical equations, the balanced chemical reactions in each case for the formation of 1 mole of product, and the associated enthalpy changes. We're then asked to determine the enthalpy change for the hydration of ethene from the data, and in this case we're going to write down a Hess's cycle in order to determine this. So let's remind ourselves what the reaction is that we're trying to work out the enthalpy change of. It's the hydration of ethene, which goes as follows: the production of ethanol as the product here, and the enthalpy change we're trying to work out is this one here. And the way we're going to do it is the following. We're going to first of all break down our reactants into their elements. Okay, so C2H4, as we've just seen, is made from 2 carbons, and 2 moles of hydrogen. Okay, and water is made from 1 mole of hydrogen and half a mole of oxygen. Okay, and then finally our next leg of the reaction will be to take all of these elements and to produce 1 mole of ethanol. Okay, and in order to work out this enthalpy change, we're going to add together the enthalpy change for these 2 processes, the blue and the red one, and also the green one, because remember we have to go round this cycle in that direction from these reactants to this product, but via a different route. That's what the essence of the Hess's cycle is. Okay, so what are the associated enthalpy changes? Well, the blue arrow that we've got here is the opposite of the formation of ethene. Okay, so the enthalpy change for that is going to be the reverse of the enthalpy change for the formation of ethene. So it's going to be minus, oops, let's change the colour there. It's going to be minus the enthalpy of formation of ethene. And it's minus because the arrow is going in the opposite direction to formation. Formation would take carbon and hydrogen and produce ethene. The reverse process with a negative in front of the enthalpy of formation gives us the enthalpy change for that process. Likewise, the enthalpy change for the red reaction that I've shown here corresponds to the reverse of the formation of water, because the arrow is going in the opposite direction. So the enthalpy change for that is going to be minus the enthalpy of formation of water, H2O. The final step in this reaction, the green arrow that I've got here, corresponds to the formation of 1 mole of ethanol from carbon and hydrogen and oxygen. And so that is simply the enthalpy of formation of ethanol, C2H5OH. Okay, so overall my enthalpy of reaction, that's what I've got here, is going to be minus the enthalpy of formation of ethene minus the enthalpy of formation of water plus the enthalpy of formation of ethanol. I've run out of space. C2H5OH. Okay, so if I then work out what that enthalpy change is going to be, I do the following. My enthalpy of reaction is going to be minus 277.7 minus 52.3 minus 285.8, which gives me minus 44.2 kilojoules per mole. Okay, so that's my answer. I've got units and I've got a sign showing it's an exothermic process, and I have a numerical value associated with it.